Hello, you're welcome to today's lesson. This time around, we want to show that the integral of ln x dx is equal to x ln x minus x plus c, where c is a constant of integration or the integration constant. Now, taking a look at this function that we have been given, that is the integral of ln x dx, to go about it, you first of all have to identify the best approach to go about. Looking at it briefly, you will realize that the best way to go about this is to use integration by parts. So in using integration by parts, we can therefore allocate our u and v part. Preferably, we will let u be equal to ln x. Then we can also let our dv to be equal to dx. When that happens, remember, at this point, at the u, you need to differentiate. This implies that differentiating u and then differentiating ln x, we will need to input what we need from here, that is du dx. So du dx is equal to 1 on x. Remember, differentiating the logarithm or logarithmic differentiation, the differential of any function of this form, that is in this case x, should be in the form 1 on x. Right, remember, we are trying to make the u the subject in this case. So making the u the subject implies we multiply both sides by dx. In that case, we will result with the u being equal to dx over x. Good. So having our dx, the next thing we can do is also to find the integral of our dv to get the v part. Good. Our dv to get the v part. So in doing so, we then have to find the integral of both ends. So find the integral of dv. So good. So the integral of dv as against the integral of dx. Good. So remember, in this case, we are going to have dv, the integral of dv going to give us v, whereas the integral of dx giving us x. Right. So at this end, we can then put these into our integration by parts formula. Integration by part formula. Remember, that formula results in the form whatever we are looking for, or the integral of whatever we are looking for, will be obtained by the product of u and v minus the integral of v du. Good. Right. So having whatever, or quoting this up, this setup, we just need to put or input whatever coefficients, whatever variables that we have already obtained. So realize that we obtain u, or initially we said u to be ln x, so we will just input ln x there. So ln x, good, minus the integral of v. So the integral of v, remember v is x, so the integral of x, and that is multiplying the u, and the u was giving us the x over x. So in that case, we put a value of the x, so we have the x over x. Now remember that this point x can deal with x, right? So when that happens, this implies that, sorry, I forgot to input the v, because we're having u and then that of v multiplying. I only inputted the u, so forgive me. That of the v here is x, so it means that times x, right? And remember that we said at this point u, the integral of v in this case, because of these similar characters, will nullify each other. We therefore having the result to being this way, where we are having the integral of only dx. Good. So the integral of only dx, because this x will modify this x, right? So the integral of dx will equally give us another form like this, where we have x, but remember we are dealing with um, an indefinite integral. So in view of that, we always need to bring our integrating constant or constant of integration. So going back to our question, remember, is to show that the integral of ln x dx is equals to x ln x minus x plus c. So that is what we have resulted to in obtaining. Thank you so much for watching, and see you again. And it's bye for now.